Welcome to the session number 10 from the playlist of circular motion. The topic is the motion of a body on a rough, banked road. And based on this topic, I have drawn here one simple diagram in which I have depicted one car which is moving on a rough inclined plane, and the inclination of this plane with the horizontal is theta. So when a body is moving on a rough banked surface, then in that case, uh, the weight of that body will be acting vertically downward. So here in this in this example, the m is the mass of the car. So the weight of the car will be equal to mg, and this will be acting vertically downward, and there will be a normal reaction which will be acting perpendicular to this plane. So I have indicated the direction of this normal. Now I have resolved this normal into two components. So this angle is theta, so this angle will also be equal to theta. So this vertical component will be equal to n cos theta, and the horizontal component will be equal to n sin theta. Now since this is a surface, since this is a rough surface, therefore the force of friction here will be acting in the direction as given by this arrow, and this force of friction, or you can say this, the force of static friction, will provide the necessary centripetal force. So the component of the static friction which will be providing the centripetal force for moving this body in a circular path will be equal to f cos theta. Similarly, n sin theta is a component of the normal reaction. So this component, that is n sin theta and f cos theta, both these two components which are acting towards the center of the circular motion will be providing the necessary centripetal force, which will be, so n sin theta plus f cos theta, this will be equal to mv square by r. So this is the first equation which we have got. Now, since in this motion there is no acceleration in the vertical direction, therefore n cos theta will be equal to mg plus f sin theta. Here this f sin theta plus mg will be equal to n cos theta. So these are the two main equations with the help of which we will be able to find the maximum speed of any body which is moving on a rough inclined surface. So from this equation number, now in order to get the maximum speed, the force of friction should be equal to mu s into n, where mu s is the coefficient of static friction. And here the most important thing which we have to remember is that it is the static friction which will be providing the necessary centripetal force along with the component of this normal reaction. This normal reaction is n sin theta plus a component of this static friction. Both these, that is f cos theta and n sin theta, which are acting towards the center of this circular path, will be providing the necessary centripetal this force. So now, in order to get the maximum speed, f will be equal to mu s into n. So what I have done is I have substituted this value in the equation number 1 and 2. Now by substituting the value of f is equal to mu s into n in 1 and 2, I have got the equation number 3 and 4. So equation number 3 is equal to mg plus mu s n sin theta is equal to n cos theta. What I have done is I have substituted the value of f is equal to mu s n into this equation. So mg f is equal to mu s n, so this will be equal to mg plus mu s n sin theta, which is equal to n cos theta. And similarly, I have also substituted this value in the equation number 1. So I have got n sin theta plus mu s n cos theta, which is equal to mb square by r. So I got these two equations. Now from equation number 3, I have got this value, that is n is equal to mg divided by cos theta minus mu s sin theta. Now by substituting this value of n in the equation number 4, in this equation number 4, I have got another equation which is equal to mg in bracket sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, which is equal to m v maximum square by r. Because after substituting the value of f which is equal to v mu s into n, we will be getting the maximum velocity, maximum speed with which this body or the vehicle will be able to move in a circular path on a rough inclined surface. So in this equation what I have done is I have simply divided the numerator and the denominator by cos theta. So by doing this I have got another equation, that is V max was equal to Rg V max square. In fact this was V max square was equal to Rg into mu s plus tan theta divided by 1 minus mu s tan theta. So this V max will be equal to under root of Rg in bracket mu s plus tan theta divided by 1 minus mu s tan theta. So here we have got this tan theta by dividing this equation on the left hand side by cos theta in the numerator and the denominator. So after that we simply got this equation, that is V max is equal to under root Rg in bracket mu s plus tan theta divided by 1 minus mu s tan theta. So this is the maximum speed with which this vehicle can move on a banked surface which is rough. And if the surface is frictionless, then mu s will be equal to 0. So in that case what we will be getting V max as under root, here mu s will be equal to 0, so simply this term will become 0, so we will be getting as tan theta Rg, tan theta into R into G. So this is the maximum speed with which a vehicle can move on a smooth surface, means a surface which is frictionless. And the maximum speed in the case of a frictionless surface will be equal to tan theta into R into G. So thank you very much for joining this session. In the next session, I will be coming up with a question which will be based on this topic, that is motion of a body on a rough inclined surface. So thank you very much for joining this session. Have a nice day. Bye.